Welcome everybody to the webinar entitled Shukla 7 Research Mantras, Tips for All. I'd like to quickly introduce myself and Ilona, my assistant. I'm Petra van Steenbergen. I'm executive editor in the Earth and Environmental Sciences team at Springer. Ilona and I, we both are working closely together with today's distinguished guest and speaker, Dr. Sanjay Kumar Shukla. And we work together on the publication of the International Journal of Geosynthetics and Ground Engineering. Professor Shukla is the founding editor-in-chief of this successful new journal. It is a great pleasure to introduce our speaker of today some further to you. Dr. Shukla is Associate Professor at the School of Engineering at Edith Cowan University in Perth, Australia. He holds several distinguished professorships in civil engineering at various universities in India and has over 24 years of experience in teaching, research, and consultancy in the field of civil geotechnical engineering. He has authored more than 260 research and technical papers, and he is also author and editor of 21 books, including 7 textbooks. He has been honored with several awards, including the most prestigious IGS Award in 2018 from the International Geosynthetics Society, IGS, in the US. And last but not least, he is Fellow of Engineers Australia and a Life Fellow of Institution of Engineers in India and Indian Geotechnical Society.
I welcome all and would like to thank for joining me at this webinar. This is an opportunity for me to share my experience as I have been able to develop by working through my own research, by leading this International Journal of Geosynthetics and Ground Engineering since 2014. So the main topic is to discuss here that how we all can do better in research. So you can see here in 2019 I designed 7 mantras to share with our young researchers, because you know that when a researcher starts her initial research, there are lots of challenges. We have books how to do research, but it is important for a young researcher to quickly go through key points. And you can notice here in this slide that I presented 7 mantras in 2019 at LinkedIn as a post, and about more than 7,000 views we can see here. And later I am being regularly contacted for any specific discussion. So today my focus is to go through these mantras and explain how these mantras can help a young researcher to have an excellent performance in terms of outputs of practical importance, in terms of high quality publications. So I do hope at the end of this webinar, those who are participating, they can have a better feel for future application. So let us start with the basic definition of research. Research refers to systematic investigation, examination, study, analysis, review of materials structures, objects, systems, phenomena, sources. So as a researcher, some of us might be working on a particular material, a particular structure, or any object, or any physical observation. So when we investigate or examine, or you can say study, analyze, that task becomes research. So basically, we are trying to develop knowledge on a new material, for a new structure or object or system or phenomenon or any source as required in real life. Now, we need to know about innovation as well. So what is innovation? It is a new idea. It may be a new method, that is way of doing something, product. Now the question is, are these two terms the same or they differ? Here you can see that they are related to each other. So a comparison can be seen here. Research contributes to knowledge, while innovation contributes to outcome. Certainly, with knowledge, we can change the outcome. It means research can lead to innovation. In our local places, wherever we work, we can see in the name of research and innovation office, research development and innovation office, business research and innovation services, center for research and innovation. So these two words are often used for naming any organization. Can I do a successful research? This is the first question, right? When a young researcher starts her research journey, that if I am, let us say, going to join as a PhD candidate, there is always this question in mind of the individual. Now, answer is here. Can you see here? This is a shelter designed and constructed by insects. Okay, so in one way, we can say that even insects can do some form of research, and that's why they are able to create their shelter in a safe place. You can notice the location of this behind the door frame. Now, next example is, suppose here you can see a tree, and you can see the diameter, and there is an excavation, and roots can be seen here, right? So I did this experiment myself, and we can understand that how even plants, trees, vegetation, they design, they construct their roots in some form. And this kind of soil is called fiber reinforced soil. You can see this is the first book on this subject. So by these two examples, what I am trying to say, that we being human beings, we can certainly do research if insects, if trees, any plant can do design construction for their survival. Yes, we can always do. Now, let us see, do we have research potential? If an individual is going to start the research journey, this question comes in mind. What is research potential? Ability that may be utilized, developed to carry out the research for future success or usefulness. We all do research every day in some form. There is no doubt about it. We all have the ability to do research. The difference is how we use it and let others to know about. Some more questions as a beginners. Can I have excellence in research for whatever we do? Can my research lead to innovation? That is, really, is it going to be utilized in real life? How to perform well in research and innovation? Now, for doing research, we need resources. Now, what is the main resource which is required for doing research? Many of us may answer, we need money, we need machine, a good laboratory. That's true. But I will say differently. We really need mind and brain. Even though we may not have proper machine, we may not have enough research grant, but certainly we can do a quality research. So mind and brain, you can say, and we all have. Every human being has mind, brain. So certainly if we have mind, we can do research. So with the mind, we need time also. Even though I have, some understanding, but we need to put time. Without putting time, we can't utilize our mind. So here I am listing mind is the first resource, then time. Plan with dedication. Even though we have time, but we are not planning with the dedication, we can't be successful. Supervision is also essential. Skill development. While doing research, everything is not known. We have to develop certain skills to achieve the objective, to research objective, the goal. Network, collaboration, support. Wherever we live, we need to take help of others. Money. Finally, money, wealth is required. There's no doubt about that. But I will never say first that I need money, then I will do research. No. Even without money, I can do research, and I will show you some good examples. We need machine because money, machine, apparatus, instruments, certainly we need for experimental work. And some of you can list more. Now, someone has said, do some research on your supervisor before you start doing research with your supervisor. This is true that whenever you start your research, you need a proper mentor, and you should try to do research with a proper mentor, but it is always not required, I must tell you. Someone can do even without any mentoring, and it has been demonstrated in the past. But in general, it helps greatly when we do research. Now, coming to research mantra number 1, what is that? Because we need to define the problem, focusing on the fact that others have not worked on the same problem, as you may confirm it based on the detailed literature review. Some of us might have experienced that when we submit our paper doesn't go well in the journal where we submit. One of the main reasons is what I am saying here. The problem may not be really a new one, because someone might have worked, similar work has been done. If similar work has been done, it is not easy to create new output, and that's why we can see some failure, some unsuccess wherever we submit. So it is first mantra is that let us define a problem which is really a new problem. No one has given attention to that. And in our paper, those who have written paper, they know that at the end of introduction section, we need to very clearly say this task has not been done in the past. But it is hard to make that kind of a statement unless we do a detailed literature review. So this is most important. And if problem is really new, any solution to this new problem, even the simplest one, I can say, may have a significant novelty and will get an easy acceptance by most research publication platforms in the related area. Now, how to define a new problem? That's the question. That may be a question coming in the mind of many of us. So let us see, we need to observe around us while walking, while driving, we can notice. So here just I am giving, this is a road, a view of the road, and you can see the closer view, what is here. Now, it looks like a civil engineering problem, many of us can say. But if you see, if you closely notice, we have problems of everyone. A chemical engineer, a material engineer, a civil engineer, even mechanical engineers can get the problem, because you know that we are applying some forces on the material. So mechanics is coming into picture. So why we can see this kind of problem worldwide here and there. So why we are not able to really get potholes free payment in our areas? If you see, we can see potholes here and there in many places. So we have to focus on, we have to identify a problem here which has really not been analyzed, not been investigated, not been examined in detail. So like that, you can see this is another site observation. Here you can see waste material, because future is about how we are going to utilize the waste material, because we have to focus on sustainability. United Nations have 17 goals. So how to utilize the waste materials so that no need to place them in landfills. What we can see here in dustbin, we can see plastic, we can see paper, we can see timber pieces, wood, we can see some glass also. So we have to see that how to define a new problem which is really not focused by any other researcher in significant detail. So just I am giving one more field view. You can see the flood situation. So the living area, the houses, buildings, they are a kind of submergence you can see. And you can see research. This person is also doing research. Can you see here what is that? That is a timber bed, and there is a tire tube, and that's the simple research they are doing. Now I can see personally scientific research here as well. So many problems are here. How to solve this kind of flood related problems? So what kind of building we should construct? What kind of materials we should utilize? So now this is another field view, site view, construction site view. You can see here a long length, and so many pillars are there, columns are there, and this is for supporting, let us say, a bridge structure. And not bridge, it is also for aqueduct come bridge, so canal water will flow at that. And so many challenges are there. I had my own consultancy advice here. The challenging task was estimating load carrying capacity at different locations, because no two ground points are identical. So when we try to find a number, how much load I can apply, answer is today, answer is also not available today in real sense. So many uncertainties are there. We need to understand, can I be able to develop a method, a system, so that we can really give more realistic estimated value of load carrying capacity. Now, underground mines, those who are working in mining areas, so many problems you can see in tunnel. Um, uh, at the tunnel base, you can see bottom seepage is there. So if this is a tunnel, how to control the seepage? It is mine tunnel, but we have tunnels in traffic tunnels. Lots of challenges are there in construction, in managing the water. We have successful tunnels, but still we have to see how we can make them more sustainable, more economical. So this is just another view of that my tunnel in the mine. Now, at the runway, at the airport, we can see that runway extension project. So when I closely observe, I can find really problems for me, which might not have been taken by others. So just I am showing these photographs from my own field works, that when we closely observe, we can really get new problems. And here just I am giving you, even though we don't have, let us say, what I say, that machine money enough, yes, we can work like Newton's laws of motion, we can work like Einstein's mass energy relationship, Ohm's law, Bohr's atomic model, Archimedes principle, Tejagi's effective stress principle. In different areas, we can see I am just presenting these fundamental classical works, mind-based research. So whenever we don't have, let us say, enough physical resources, if I am a researcher, I will not stop myself. I will focus that, yes, I will define my problem in a way that will the solution is going to be useful. Not exactly, it's not easy to every day create Newton's laws of motion, but the basic objective in sharing these laws and these fundamental research to say that yes, still we can do many types of research without physical resources. And I have demonstrated my expressions. You can see Shukla generalized expressions now have become textbook material, and recently it has been cited well in one of the sections in popular geotechnical engineering book published in United States. So what I say, that how I develop, you can see here just brain work, and several days, especially late evening, I have worked, and this problem, because this is the retaining wall, we need to calculate pressure on in the back under the seismic loading, all field conditions. You can see most field conditions, as we can see, have been considered to develop a formula. So calculator is required, no software to calculate the value, but we have commercial software these days, and we all know challenges when we work with software. It's not easy for the same problem. If you do a software based solution, answers are not going to be unique. So there are challenges there, but once we learn skills and some knowledge how to select input parameters to get my desired output, yes, software can do a lot, and they are doing, but for initial design, or whenever we don't have software, we need a fundamental formula, fundamental expression, so that easy to calculate. So just showing you that now you can see mind-based research, that how we can suppose aircraft is going to landing, this is the touchdown point. So suppose I want to calculate deflection. How we can calculate deflection at the touchdown point during landing? Yes, we can see that we have done a work, and that is published in the International Journal of Geomechanics, and that is very basic work, very simple work, but this is a reputed journal and they accepted. So just I am showing you that we need to define our problem in a way that nobody has worked. Some more work you can say here, it is in mechanical engineering. I am basically a civil engineer, specialized in geotechnical engineering, but you see, the second author is a mechanical engineer, and he discussed some problem with me, and I studied and find that engineers are using some approximate equation for designing the storage vessel, and I developed a more realistic mathematical expression for design of a storage vessel basically. Now another, you can see that Poisson's ratio, because generally this is one of the elastic constant. We can't calculate Poisson's ratio at zero strain, but we talked about, because if you know the Poisson's ratio at zero strain for any material, you know that will be the valuable parameter to identify the material, but practically it is not possible, but I have explained how it can be done. Now coming to research mantra number 2, do the experimental and or mathematical work with a great accuracy. Okay, it is because suppose we have defined a new problem, but if we are not caring for our measurements, our mathematical analysis, there is no meaning in doing that research aiming at high quality, highly useful outputs. So accuracy is very important, and while doing research, how we can achieve great accuracy? While doing research, do not believe the accuracy, correctness of whatever you use. Expect your own mind. In order to achieve the goal, you must verify yourself. I will give a simple example. If you are going to use balance, digital balance or physical balance, you need to check yourself. You should not assume that balance is giving me the right answer. So whatever tools you are going to use, measuring tools, sensors, any device, first do calibration. Please check. Otherwise, your whole work, if some error is there and you have put your significant time, there is no meaning of that output. And I have noticed that many students, they start doing, going in the lab, and they started doing some measurement without checking the balance, and they have not been aware that balance was faulty, some problem was there. So all measuring tools, equipment must be checked with proper calibration. So I'm just giving an example that this is whatever you see. This is a landfill site, and you can see the geosynthetic clay liner at the bottom. And here, this is the leachate collection pond. And here you can see it looks like a plastic sheet, but technically it is called geomembrane liner, because leachate is pumped out from the landfill pit, and that is placed in this pond for treatment and further disposal. So the idea was that one of my PhD student, she did a work on a leak detection technique, that how we can detect that whether there is a leakage or not, even though we are using some form of liner. So now you can see money is required, but if you see this setup, what do you think? Do you think that it requires really a big amount? No, it is just I can say just $200-300. That's all. So a very low cost fabrication, you can say. So this fabrication was done, and the measurements have been done, and finally we have explained here that how electrical resistivity can change with leakage duration. So if I can measure at the site electrical resistivity change, that is because of leakage, right? So this graphical presentation is a kind of design chart, and it can help me in identifying that whether there is a leakage or not. And an excellent paper in International Journal of Geotechnical and Geoenvironmental Engineering got published in 2020. So just I am giving an example that how simple, mind-based work with limited resources, because always physical resources are limited at any place we can observe, we experience. Now, I talked about that we need to do the measurement with accuracy. So error and uncertainty we need to understand. And most of us know from our school days, high school, that measured value can never be exactly true for a number of reasons. Any equipment, instrument, or measuring tool is manufactured to a certain level of precision. Human factors also contribute to inaccuracy of the measurement. Accuracy, precision, and error have a specific meanings in the context of measurement, and we need to know about whenever we do experimental work or even mathematical work. So accuracy is a measure of reliability. It refers to degree of perfection obtained in the measurement. In other words, how close the measurement is to the true value. Accuracy can be calculated from the difference of true value and most probable value. Most probable value is derived from a set of measurements. It might be the arithmetic mean of a number of independent measurements. Since the true value is never known, it is impossible for the accuracy to be known. It can only be estimated. Accuracy can be estimated from residuals. So here just I am going to explain. You can see that simple length measurement, even length measurement, if you see, if we are measuring a length AB, you can see it is repetitions, and mean you can see 25.32, and when we are finding residuals, one case, another line you can see measurements have been made several times, mean is there, and now residuals are limited. So when residuals are really low, that means that we are getting high precision. So this is here this is key information that whenever we do our research, we have to care for accuracy and precision. And you should note that precision refers to the degree of perfection used in the instrument, methods, and observation. In other words, to the level of refinement and care of the measurement. In summary, precision refers to degree of perfection used in the measurement. Accuracy refers to degree of perfection obtained in the results. In a series of independent measurements of the same quantity, the closer each measurement is to the mean value, the better is the precision. High precision is costly, but it is generally necessary for high accuracy. High precision is not always a guarantee of high accuracy if blunders and errors have not first been eliminated from the work. So that's why I'm saying, particularly if you are doing experimental work, even though you are trying to achieve high precision, there is no guarantee that your values are going to be highly accurate. You can see here, if a measuring tape, let us say simple length measurement, someone has measured all 5 very close, so you can see that good precision, but accuracy is poor because the actual length is 300 meters, because the measurements, 5 measurements made with a wrong tape, incorrect tape. And in second case, you can say that whatever reasons, all values are scattered. So precision is poor, but Fortunately, the good accuracy you can get, but this is not going to happen always. And our expectation is really good precision and good accuracy. All values should be closer, and when we compare from each other, and also to the expected value. Now, error is difference between an actual true value and an estimate of the true value. If the estimate is a bad one, then the error will be large. And so in brief, I can say that yes, we need to really know about accuracy, precision, error. The best estimate of accuracy is usually the precision, but it will usually be over optimistic. Now, you can see some of you might be reporting even technical reports, significant figures. Many of us, do calculation and report so many digits. But we need to understand that last point, accuracy of measured values cannot be improved by the computational processes to which it is subjected. And just here I'll give an example that two significant figures, 20, right, 3, so all 2 here, although looks digits more. So we need to have good understanding. Suppose a specific gravity of any material, we need to present it in 2 decimal, but even though it is 2.1, I should write 2.10. So we need to understand which parameter requires how many significant figures in our report. This is another site observation, and here I am explaining a large load test. So you can see the whole arrangement, and measurement, measured values depends on whatever I am using the tools here, equipment, measuring, and it all depends on really how they are, what is the list count of these measuring tools. Like here dial gauge, you can see here pressure gauge is there. So this is hydraulic jack. Now coming to research mantra 3, the limitations of your work must be known and discuss them suitably in your article. Many papers are not accepted. Do you know that things are not clear? You have not mentioned. So some of us avoid writing limitations of our own work. No, please try to write clearly that what are the limitations of your work. That adds a great value to the article. Research mantra 4 is always try to explain the mechanism of your observation, findings at nano, micro, macro level as possible, and attempt to develop scientific theory, equation, design chart, design table for field application. So you might be getting observation that there is increase of a parameter. It is important to explain why that increase. Okay, so mechanism is important in research. Just explaining that okay, some parameter increases, decreases, that is not really enough. So that's why always try to include mechanism in our research. Do put time on analyzing at nano, micro, macro, whatever possible, and at the end you need to develop some useful equation, theory, design chart, design table, design guidelines for field application. Here just I am giving one example from my own. I developed a method to reinforce the foundation soil by a wraparound reinforcement technique during 2007 and 8. And at that time I had no theory. Actually it is all based on mind analysis, and I have applied this with some simple calculation, and in real life many researchers have reported that if it is a loaded footing, in the foundation we can place several layers of reinforcement. Generally they are geogrid layers or woven geotextile layers, okay, at certain spacing, vertical spacing, and let us say 2 layers, 3 layers, 4 layers. Normally more than 3, 4 layers is not recommended. enough research is available. But this is what is the problem here, that we need a large area. Can you see here, b a large value is required, and at many places we don't have large width of land. And so just here you can see what I had done, that I said, okay, let us go for wraparound ends, so that we can reduce the requirement of land width. And not that, other benefit is that we are getting more load carrying capacity, we can apply more load. So this technique has been studied in detail in the laboratory, and our one of the initial paper was published in International Journal of Geosynthetics and Ground Engineering. And many different aspects of this work has been published in different journals. And this is what I am talking about, mechanism. So we explained that how wraparound end is going to benefit in the increase in the load. Okay, so this is just an example. In different areas we need to see that what kind of mechanism can be studied, explained. And this is just an example of field application. You can see in the road subgrade, then you have needle punch, nonwoven geotextile, and sewn joints, because we need to join two sheets whenever we are using. And coming to research tip number 5, compare your work with previous approaches and or similar solutions if available. Because whenever we work, always it may not be completely new, it may be improved. So we need to compare from the previous. You can see here, very recently, a few weeks ago, you can see that someone has compared my research, which I talked about in the beginning, Shukla, and they say Shukla method. So like that, in graphical form they compared, and they compared in tabular form also. Okay, and can you see my formula requires only calculator, so you can see that measured value is closer, although it is analytical expression. So but comparison is required. Coming to research tip or mantra 6, always describe your work using short and clear sentences in simple and plain English, and avoid grammatical and presentation errors. That is very important. A strong presentation is required, even though you have excellent research output. With poor presentation, work cannot go well. And finally, research tip number 7, there should not be any rush that can cause errors in your work. Now, I am going to show you some examples, good examples, and explaining some really, I will say, not good example, but that demonstrate that researchers have really not cared a lot, and they have been in rush. So this is one of the best examples. Can you see the title? Evaluation of coefficients of subgrade reaction. Those who are from civil engineering, they can get it well, but certainly if electrical engineers are there, mechanical, I think they might not be getting. But I must say that this is a great paper, Evaluation of Coefficients of Subgrade Reaction by Carl Terjagi, who has been father of soil mechanics, who developed the subject soil mechanics, we can say geotechnical engineering. So very short title. Can you see? Everyone can quickly go. What is the next? This is from my own paper. Title can be like this: can soil arching be insensitive to phi? This is the title. Now, this is another title from my own work, tailored slope stability chart. So you can see. So what I am showing you, some titles, well designed titles. This is also a good paper, but if you read the title is going really too long, and as a reader, some of us may not like too long, but this is a very good paper, in material science and engineering. Now see, researchers are in rush. Where is the y-axis? Where is the x-axis? And this is in published paper. So that's I am showing you that even though sometimes in published paper you can find that proper care has not been given, and if you closely observe this photograph, I will say that much improvement is required even though it is published. Now you can see the photograph looks good, but background, if you see, why this background, many things are coming in background. We need to know the skills, how to take better photographs. This is from my own work, and you can see well designed, well presented graphical presentation, and a good example. So you can see the graphic and the line sketches nicely presented in one of the best journals, you can say, Geotechnic, from my own work. And now can you see this table? This table, if you closely see, poorly typed, although it is published table. Now this is also, you can see, it is published in a journal, and just I am explaining here. If you see the SI unit, kilonewton per cubic meter, but this is maximum dry density. So density has been reported in kilonewton per cubic meter. No, it is maximum dry unit weight. So so a care is required, right? Even though published great paper, but we should avoid that kind of otherwise, if during review reviewers will be unhappy and they will doubt the correctness of the work, that if they are not able to present, how I can believe that work has gone well. And I think I am closer to the end. Best research practice summary I am giving you. 5 pillars: 3, 5, 7, 9, 11. Why? Plan your research. So 3 words. 3. Manage and record your research. 5 words. Select, analyze, and present your research data. Publish your key research finding at a scholarly publication platform. Communicate your recognized research worldwide. Being responsible researcher professionally and socially. I say 5 pillars: 3, 5, 7, 9, 11. Because the way I designed, I used 3 words, 5 words, 7 words, 9 words, and 11 words. So this is the summary. And learning never ends, we all know. Let us work together and create a healthy working environment with valuable developments, finding outputs for all in this century and beyond. And here you can see Petra has already introduced, but all of you can be in contact through email, and other social platforms are also there, LinkedIn. Now finally, what I am going to say, that we should consider us, that yes, if we have engineering background, certainly we are engineer. When we do research, we work like scientists, and generally we should depend on our mind, not heavily on machine and money, because these two may not always be available. I believe any work done with mind lasts long. And geotechnical engineering, because my specialization is geotechnical engineering, so I am summarizing as geotechnical engineering principles. Always need engineering judgment to provide solutions to geotechnical geoengineering problems, and similar concept is required in other areas as well. So geotechnical engineering is a science, but its practice is an art. And thank you all for your patience.